Good morning, early MoPar owners. It was clear from my post about restoring this cluster that there was a little confusion or not understanding how these gauges actually work and what I was doing. So these early ones actually have the voltage regulator built into the gas gauge. This is for an A100. My Dart has that, which is 63. And later on, they actually went and took the actual regulator out of the gas gauge and put it onto the back of the clusters. Usually it's just got a screw holding it on there, and it looks sort of like this. Not exactly. This is an electronic version, but they're much easier to change. So what I'm doing here is, because these old gauges are so rare and so difficult to repair, right now I believe there's 2 or 3 people in the country that actually have the correct wire to do it. I tend to buy these electronic ones from Real Time Engineering. There's 2 different styles. One's a direct plug-in to the original ones that plug into the back of the cluster for the later cars. This one is more made to be just standalone regulator, just voltage in, regulated voltage out. These just get voltage somewhere and then you run the wire. And what they're really doing is, if we go inside this gauge, so let's see how this works. 12 volts is connected to the stud right here, comes up this bond wire to this point contact. You can't hardly see it, but that's actually insulated. So this side of the points is 12 volts, but it's not tied to this metal frame right here. There's insulating pads on both sides. So that's how you get 12 volts in. So now you've got 12 volts. If the points are closed, you get 12 volts that actually feeds through this frame, comes over, and now this pad down here is 12 volts as well. But also there's a wire, the thermal wire, connected right to this end of the coil right here near the points, and it goes through this heating wire coil. The other end goes to ground. So let's imagine what happens as that heats. It deforms this bimetallic strip, and this piece bends back and opens the points. At that point, there's no more voltage on this side, so this whole metal frame is now dead. The heater coil is disconnected and it starts to cool back down. Cools enough, it bends back, it closes, and it just repeats that cycle: open and close, open and close, open and close. And it happens around every 50 milliseconds. So now if you look at the other wires down here with this thermal epoxy, or not thermal, but the conductive epoxy, it's also connected to the wire that comes up to the thermal wire here on the actual gauge itself, with the other end runs down and goes down to this pad. So this is the pad that goes out to your gauge sensor. So that gives you the variable resistance on your gauge. And then that's what defines how far this needle moves. Because as this is pulsing 12 volts, remember this end is tied to the side of the points that are pulsing on and off. You're putting 12 0, 12 0, but then you're changing the current by how much gas is in the tank, or what's the thermal temperature of the engine. That actually defines how much current goes through this wire, how hot it gets. And depending on how hot it's getting, it moves this a little different position. So that's how this all works. The reason I know this is in good shape is, the reason these fail is this wire is insulated, right? If it's wrapped around that metal bimetallic strip and it wasn't insulated, it would just short it out everywhere. When these things get old, what happens is usually 2 things. That insulation just completely deteriorates from age, or these points will stick and just put 12 volts on those wires at all times, and that'll burn them out pretty quick. So it doesn't look like this one's ever had a problem. If you take your ohm meter and go between the terminals that will actually take you across this coil wire, they should read around 20.6 to 21 ohms. And there's about a foot of wire in there. So trying to find nichrome wire of that diameter at about 21 ohms per inch is impossible because they don't make any new stuff. The 3 people in the country that actually can restore these have bought up all the new old stock wire that they could find. So what I'm doing here is I'm replacing this original bimetallic strip that turns on and off at 50 milliseconds with a microprocessor controlled one from Real Time Engineering. These have built-in current control so that if they sense the current's too high, they'll shut the whole thing down so you don't burn up any other gauges if one of them does happen to go bad. You don't have to worry about the bimetallic strip failing. They do. Remember the old points on the alternators. That's usually the first thing you want to get rid of is those old regulators for that exact reason. Because those bimetallic strips do wear out over time. And what I'm doing is I'm just going to cut this one wire in here that takes the coil around the points to ground, and I'm just going to cut that ground wire. I want the points to stay shut so that when I feed 12 volts in here, it'll just go through the points, through to the pad, and then power this coil here for the gauge itself. The actual pulsing will come in externally, and I'll put 12 volts into this side, and out on this side, you'll get your 50 millisecond 12 volt pulses, and that's what I'm going to tie in to here to the old 12 volt DC, and then that'll be pulsing on and off. The points will always be closed, so now my gauge will actually get the 50 millisecond pulsing from this. Temperature gauge and or oil gauge would be the same thing. You would just tie in to this pulsing side, run over to the temperature gauge, and hook it up to where this used to be, because there's actually a post out the back of the side that used to pulse, and that's where the other gauges got their power, because that would be pulsing on and off. So now I would just take whatever was tied to this post that used to pulse and tie it to here where you would get your pulsing. So I hope that makes sense and clears up some questions. If not, just let me know.